So on this problem it says a motorboat is crossing a river at an angle of 58 degrees to the shore at a rate of 20 miles per hour. The river is flowing at 6 miles per hour. Describe the resultant vector speed and direction of the boat. So the picture is drawn for you on your worksheet. This isn't really how we add the vectors together. So let's show how the vectors are added together. We have the boat vector, which is 20 miles per hour. We'll call this the boat vector. It's got a magnitude of 20 and a direction of 58 degrees. And then we have the current vector, and that is just straight across 6 miles per hour, and it's an angle of 0 degrees. And so when we add these two vectors together, typically when we look at this, we have the first vector and then the second vector. We start from the tip of the other, and our resultant vector, we'll do in green here, would be the beginning to the final end. So the way we're going to do this is we're going to look at the x and y components of the boat vector and the x and y components of the current vector. And when we add those together, that's going to give us our final resultant vector components. So let's figure this out. The current one's pretty easy. That's just 6 in the x direction and it's 0 in the y direction, so we're good to go there. The boat vector we have to do a little bit of math on. So let's go over here and do the boat vector. So we've got kind of like our hypotenuse thingy here. We have our x component and our y component. We know this is 20 and the angle's 58 degrees. And so if I want to figure out the x is going to be, well, let me back up here. We'll take it one step behind. To figure out the x, this is the adjacent side, the x is, and the 20 is the hypotenuse side. So we're going to use cosine. Cosine 58 equals x over 20. Just going back to basic trig. And so we multiply by 20. And when I type in cosine 58 times 20, my x value is 10.6. So I just need a calculator for this. So there's our x component of our vector. I can put that in down in the x component. And then we'll figure out the y component. The y value is the opposite side of 58 degrees, and 20 is the hypotenuse. So we're going to use sine of 58 equals y over 20. We type that into our calculator. We'll do sine of 58 times 20. And I get 16.96. So if we round that like the other one, we get 17.0. So if we want to find this resultant vector, we're going to take 10.6, because that's the x coordinate, or that's the x value of the boat vector, plus 6, that's the x value of the current. They're both pushing the boat downstream. One is contributing 10.6 miles per hour downstream, and the other, the current, is contributing 6 miles per hour downstream. So it's pushing it downstream at a rate of 16.6 miles per hour. And then it's heading in the y direction, or across the river, at a rate of 17.0 miles per hour. So we have our resultant x and y coordinates. So what I'm going to do, I'm going to kind of shrink this stuff a little bit so I can figure out what the magnitude and direction are. So let me draw this over here. I've got an x value of 16.6 and a y value of 17.0. And I want to find the magnitude, which is the length of that hypotenuse, and I want to find the direction, which is theta. So to figure out the magnitude, I'm going to do Pythagorean theorem. 16.6 squared plus 17.0 squared equals c squared. So I'm going to type that into my calculator. And when I type that into my calculator, I get c equals 23.8 approximately. And then if I want to figure out this angle, theta, I'm going to use tangent, because we have opposite and adjacent. So I'm going to do tangent inverse to find the angle of 17.0 over 16.6. And that gives me an angle of, I'll type it into my calculator here, and I get 45.7 degrees. So I have my magnitude and my, oops, sorry, that's not magnitude. This is the direction. I have the direction and the magnitude. And we're done. In problem 2 here it says, two tugboats push a barge with forces and angles shown below. Find the magnitude and direction of the resultant vector. So we've got boat 1 that is pushing on this barge at an angle of 15 degrees with a 100-pound force. And then boat 2, this isn't necessarily drawn to scale very accurately, but it's got an 80-degree angle and it's pushing at a 2,000-pound force. So what we're going to do is we're going to look at it like we do our other vector problems. We're going to add these two vectors together, the x and y components, and find the resultant vector. So let's start with the blue vector, the 1,000-pound vector. We'll call that boat 1. And when we're going to add to that boat 2 vector. And when we do that, we're going to get our resultant vector. So let's figure out the x and y components of boat 1, and then we'll add to it the x and y components of boat 2, and then we'll get our answer, or our resultant x and y components. So let's figure out the first one. Here's our first vector. It's got a 15-degree angle, and it has a 1,000-pound force acting upon it. So I'm kind of running out of room down here. We'll figure out boat 1 up here. It's 15 degrees. I don't like that. Let's start fresh. So we've got, this is 1,000. We're going to have our x component, we'll call this x1. Then our y component, we'll call that y1. So to figure out the x component, we're going to use cosine, because this is our 15-degree angle right here. So it's going to be cosine of 15 degrees equals x1 over 1,000. So I grabbed my handy-dandy calculator and I figured out that by multiplying by 1,000 to cosine of 15, I got x1 to equal 965.9. 965.9. Sorry about my chicken scratch there. So my x component is 965.9. And then to find the y component, I'm going to use sine. So it'll be sine of 15 degrees equals y1 over 1,000. And so I type that into my calculator. Sine of 15 times 1,000. And I get 258.8. So I have my x and y components for the first boat pushing on the barge, tugboat. Let's figure out for boat number 2. So this one, oh, I already realized I made a minor mistake. This y component here is going down, so that's going to be a negative. So we'd have a negative 258.8 down there. So let's look at our second tugboat. That's pushing boat 2. That's pushing at an 80-degree angle. And it's got a force of 2,000 pounds, so it's the vector has a magnitude of 2,000 is what I'm trying to say. So we'll call this x2, y2, and these both are going to be positive because they're going to the right and then up, so we don't have to worry about any negative signs here. So to find x2, we're going to use cosine. Cosine of 80 equals x2 over 2,000. So we'll type that in, cosine 80 times 2,000. And we get 347.3. So 347.3. And then to figure out the y component, we're going to do sine of 80 equals y2 over 2,000. So we type that into our calculator, sine of 80 times 2,000, and we get 1,969.6. 69.6, pardon me there. So 1969.6. So our resultant vector is going to be where we add the two x values together. So that's 347.3 plus 965.9. And I get 1,313.2. And then I'm going to add the two y components. And remember, the y component on boat number 1 is negative, so we're going to have 1,969.6 minus 258.8. And that gives me 1,710.8. So we have our x and y components of the resultant vector. So now we need to find the magnitude and direction. Whoa, my barge and boat things didn't connect with those. Let's see if I can do that here. Well, there the barge stuck with it. We'll just kind of ignore the boats for a minute. So I want to find the magnitude and direction. I know it's going to be heading up and to the right because these are both positive. The x component is going to be 1,313.2 and the y component is 1,710.8. So I need to find the magnitude and I need to find the direction. So to find the magnitude, we're going to do 1710.8 squared plus 1313.2 squared, and that's going to equal the magnitude squared. And so we'll type into our calculator and get a magnitude of 2156.7. 2156.7 newtons of force, or pounds of force, I'm sorry. 2156.7. And then to figure out our direction, theta, we're going to do the inverse tangent of 1,710.8 divided by 1,313.2, and that gives us a theta of 52.5 degrees. So we've got our direction, 52.5, and our magnitude, which is 2,156.7. And we're done. On this problem, we've got an instrument panel on an airplane stating that its airspeed is 250 miles an hour and its compass heading is 35 degrees south of west. but there's a steady wind 20 miles an hour blowing out of the south. Find the plane's actual speed and direction. So I see two vectors here. I see the plane vector, and the plane vector is 250 miles per hour heading 35 degrees south of west. So what does that mean? If we've got a compass, where this is north, west, east, and south, 35 degrees south of west would be somewhere over here. So that would be the direction the plane is traveling. So we've got two vectors. We've got the plane that's going 250 miles an hour at a 35-degree angle. Whoop. Let's try that again. A little better. And then we have a second vector, and that's the wind, and it's a steady 20-mile-an-hour wind blowing out of the south. So the wind is blowing at 20 miles per hour that way out of the south. So that means the resultant vector is going to be from the initial point of where we started drawing our vector picture to where it ends up on the end of that wind vector. So what we have to do is figure out the x and y components and then find the magnitude and direction of this new green resultant vector. So what we're going to do, as we do with all of these problems, is we're going to find the x and y components of each part and then add them together to get our resultant vector. So I'm just going to kind of set it up here. I didn't give myself enough room, I see. So the wind vector, it's kind of done for us. It's not moving horizontally at all, so it's 0. And then the y direction is 20. The plane, I know the x and y are both going to be negative because it's heading down and to the left, so that's negative if you think of this as like an xy axis. So now what I need to do is figure out what the x and y coordinates are on that plane vector. And when I add these two components together, it's going to give us what the components are on that green resultant vector. So let's look at our plane vector. That says plane, if you can't read my writing. And so we have a vector here with a magnitude of 250. And we need to find the x component and the y component. We know our angle is 35 degrees. So I'm going to start with the x component. To find that, I'm going to just use trig. So cosine of 35 degrees equals x over 250. And I plug that into my calculator, and I get x equals 204.8. So it's heading in the x direction, or to the west, at a rate of 204.8 miles per hour. And since it's heading west, that's kind of negative on our coordinate plane, so that's why it's negative 204.8. So to figure out the y component, we're going to do, just going to kind of section this off, we'll do sine of 35 degrees equals y over 250. And when I plug that into my calculator, I get 143.4. So it's heading south, technically, at a rate of 143.4. So what we're going to do is we see the plane is heading to the west and then south at a rate of 204.8 miles an hour and 143.4 miles an hour, but then the wind is blowing it up to the north. It's coming out of the south to the north at a rate of 20 miles per hour. So we're going to add the component vectors together. We're going to take negative 204.8 plus 0, and we get negative 204.8. And then we're going to take negative 143.4 and add that to 20. and that's going to give us negative 123.4. Sorry, that got kind of squished there. So now that we have the components, I'm going to get rid of this to give myself a little bit of room. Now that we have the components of our resultant vector, we can figure out the magnitude and direction. So I know my x and I know my y. My x is negative 204.8 and my y is negative 123.4. And my resultant vector, I can find the magnitude by doing negative 204.8 squared plus negative 123.4 squared, and that's going to equal my magnitude squared. And when I type this into my calculator, my magnitude is 239.1 miles per hour. So next we need to find our direction, and our direction is that theta. And whatever we get for this theta, remember due west is 180 degrees, and so we're just going to take whatever this angle is and add it to 180 degrees. So to get that angle, I'm going to do tangent inverse of negative 123.4 over negative 204.8. And I'm going to type that into my calculator, and I get 31.1 degrees. So this angle, the angle of the direction, it's 31.1 degrees south of west, is how we would say it. So that would be our direction. You could also say 211.1 degrees. That would tell you that it's heading south of west or in quadrant 3. So there we have the airplane problem. So in this problem it says Scott pulls with a force of 400 newtons at an angle of 65 degrees with the horizontal. Mr. Ames pulls with a force of 600 newtons with an angle of 110 degrees with the horizontal. Draw a picture and find the direction and magnitude of the resultant vector. So let's look at Scott's vector first of all. We'll do Scott in red. So Scott's vector is a force of 400 newtons and an angle of 65 degrees with the horizontal. So 65 degrees is maybe like that, and this is 400 newtons. Okay, and then you got Mr. Ames, Scott's dad. We'll say Mr. A. His pulls with a 600 Newton force with a 110 degree angle with the horizontal. So we're talking somewhere which would be like in quadrant 2. It's a 600 Newton force, and this is a 110 angle. So we're talking a reference angle of 70 degrees here. Okay? So what it's saying is draw a picture and find the direction and magnitude of the resultant vector. We kind of have a picture. I can do a little bit more accurate picture, I guess. So we're going to have a 400 Newton vector with a 65 degree angle with the horizontal. And then from there, Mr. Ames is going to go at a 110 degree angle and a 600 Newton force. So our resultant vector is going to be something like this. Okay, so we're going to have to figure out what that resultant vector is. We'll find the x and y components of Scott's vector. We'll find the x and y components of Mr. Ames's vector. We'll add them together, and that will give us the x and y components of the resultant vector. And then from there we can figure out the direction and magnitude. So let's find the x component for Scott's. we're finding the adjacent side, so it's going to be cosine of 65 degrees times 400. And when I type that in my calculator, I get 169.0 newtons. So that's the x component of that vector. The y component is going to be sine of 65, because we're finding the opposite of the 65 degree angle. This is the y component, times 400. And so I'm going to type that into my calculator, and I get 362.5. Both of these are going to be positive because it's heading in the positive x direction this way, and it's heading in the positive y direction that way. So, on to Mr. Ames's x and y components. His x component here, we're going to do cosine. You could either do the reference angle here, which is 70, or you could do 110. If you do 70, it's going to give you a positive answer. You just have to remember to make it negative because it's heading in the left direction. The cosine 110 will give you a negative answer. And then times, not 400 this time, right? And this would be 600. So I'll type that into my calculator. And for the x component, I get negative 205.2. So let's figure out the y component. We do sine of 110 times 600. And that's going to give us the y value. That's going to be positive. So I'll type that into my calculator, and I get 563.8. So the resultant vector is we're going to add the two x's together, and then we're going to add the two y's together, and that's going to give us our x and y values of the resultant vector. So I'll type that in my calculator right now, and I get, for my x, I get 36.2, and then for my y, I get 926.3. So I have my x and my y components of my resultant vector. And so if I kind of take this picture here and just focus on the green arrow, the resultant vector, it's going to look something like this, where my x is 36.2 and my y is 926.3. So I'm going to shrink this a little bit here, and I want to find the magnitude m of my resultant vector. So I'm going to do 926.3 squared plus 36.2 squared, and that's going to give my magnitude squared. So let me type that in, and I get 927 for my magnitude. 927.0. So they're pulling up at a force of 927 newtons in that kind of diagonal direction. So then we need to figure out what the theta is, what angle they're pulling up at. So we do tangent inverse of 926.3 over 36.2. And when I do that, let's see, 926.3 over 36.2, I get 87.8 degrees. So our direction is 87.8 degrees. And there you have it.